Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the lecture number 8 of electronics. Okay. Uh, And also guys, before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. And also guys, share with your friends as well so that they will also be able to watch my free live lectures. Okay, and they will also be benefited by it. Okay guys, so let's get started. So last time guys, class was ended automatically because of technical error, right? And I solved one question related to capacitor. Okay, so now I'm starting with discharging of capacitor. Okay, charging of capacitor I have already explained in my previous lecture. Okay, so discharging of capacitor. Discharging of capacitor. Okay, I'll make a diagram. So this is the circuit guys. This is capacitor plus Q charge it here and plus minus Q charge it. Okay, this is the resistance R. Okay, so this is I'm going to discuss discharging of capacitor. Okay, so since we know Q equal to CV, okay, so this implies value of V is going to be Q upon C. Okay, so now in this circuit, this is the capacitor, this is the resistance. Okay, we will use KVL. Okay, loop. KVL in the loop. So if you use KVL in the loop, so this is going to be this plus to minus, right? So this is going to be V value. The voltage at this capacitor is going to be this Q upon C. So this is going to be minus Q upon C minus current is I, okay, minus IR is going to be equal to 0. So from here value of I is going to be minus Q upon RC. Minus Q upon RC, okay. And now we have this value, right? I equal to minus Q upon RC. And now we know I value is dQ upon dt, right? dQ upon dt. So this is going to be minus Q upon RC. Now what we are going to do is, so we can write like this, dQ upon Q, okay, is going to be equal to dt upon RC, minus dt upon RC, okay. Now we'll integrate it, okay, and this here it's a discharging, okay. So let's the initial charge is Q, so this is going to be Q0 to Q, okay, Q0 to Q, and this is minus and this is going to be time. Initially time is 0 to t. At time t, that charge, okay, that got discharged. Okay, so charge was q0. At time t, the charge remained q. Okay, this one. So from here we'll integrate it, right? So this is going to be ln q upon q0, ln q upon q0 ln q upon q0, that is going to be equal to minus t upon rc, right? Or from here q is going to be equal to this one. Q upon q is going to be q0 ln q0 e to the power minus t upon rc. This one, very simple, guys. So log will take so so this is the one, right? Will you use log property? So q upon q0 is going to be e to the power minus t upon rc, and q we have taken in right hand side, so that's why value of q is q0 e to the power minus t upon rc, right? So this is the charge. Or we know guys, this one, since we know I equal to dq upon dt, right? So it means we'll differentiate this q with respect to t, right? So this is going to be minus q0 upon rc e to the power minus t upon rc. Okay, or we can write I is going to be minus I0 e to the power minus t upon rc. In case of charging, we have seen I equal to I0 I0 e to the power minus t upon rc, right? Which in case of charging we have seen. So in case of discharging, sign will be changed. Okay, so this will be I equal to I0 e to the power minus t upon rc. Okay, so this is the case of discharging. This is charging of capacitor, and this is discharging. This is discharging. Okay, so this is the case of discharging, right? Or if you draw the plot here, that is t versus q, and this value is q0. Okay, so this is going to be like this one. Okay, this is the graph q versus t in case of discharging. Okay, and in charging case, in case of charging, I curve and q curve are going to be, this is discharging, guys. Last time class was ended, so that's why I was not able to make diagram for charging, that graph for charging. So I'm going to plot here. Okay, this is q versus t. Okay, so this is this, guys. This is the q curve, guys, and this is I curve. Okay, I curve, and this is q curve. Okay, so this is q curve, this is I curve, q versus t. Okay, these are the graph. Okay, this is current graph, and this is the charge graph in qt, and this is the current graph. Okay, next there is a question we are going to solve. Okay, question is, This is a good question, guys. We'll solve it using Thevenin theorem. Okay, I have explained Thevenin theorem. Okay. Okay, so this is the uh, circuit. This is 10 volt and this is 3 kilo ohm. This is 3 kilo ohm and this is 6 kilo ohm. This is 6 kilo ohm. This is 2 kilo ohm. Okay, and we have to find current through 2 kilo ohm. Okay, current through 2 kilo ohm. Okay, that's what we need to find out. Okay, so how we are going to solve it? We will solve it by using Thevenin theorem, right? So first step is we'll open the resistor. Okay, we'll open this circuit at this resistor. So this is going to be like this. This circuit is going to be equivalent circuit. This one. This is the one, right? Meanwhile, just let me check whether I'm audible or not, guys. Then I'll proceed further. Open the register. Okay, we'll open. Yeah, I'm audible. So I'll proceed further. Okay. This is A and this is B. Okay. So now what we are going to do is this is 3, this is 10. Okay, this is 3 kilo ohm or R kilo ohm. Okay, this is 6 and this is 6. Okay. So first we are going. So first we'll find R Thevenin. Okay, R Thevenin. Okay, R Thevenin. For R Thevenin, we'll short will short circuit the batteries, right? All batteries. So this figure is going to be like this. This one. Okay, this is A, this is B, this is 3, this is 6. These are kilo ohm. Okay, in kilo ohm, this is 6 and this is 6. So here we can see these two are in series, these two are parallel, and then uh, this series, their sum is parallel to their parallel, right? So this means I'll show you 3 is in series with 6. Okay, sorry, this is 3 ohm. Okay, and plus, not plus. Okay, so then this is parallel with 6 is parallel with 6. Okay, so this means this is going to be R Thevenin is going to be, these two are in series means 3 plus 3. and this is parallel with this. These two are in parallel means 6 into 6 upon 6 plus 6, right? So this value is going to be 6 parallel with 36 upon 12, right? So this implies uh, 6 parallel with 3, right? And this implies 6 into 3 upon 6 plus 3, that is 18 by 9, right? That is 2 kilo ohm. Okay, so Thevenin, that R Thevenin is 2 kilo ohm. R Thevenin is 2 kilo ohm. Very simple. Okay, next is we'll find V Thevenin. Okay, for finding V Thevenin, what we can do is uh, we'll find first these two are in parallel, right? So we'll get the equivalent resistance. So they are in parallel means this is going to be 6 into 6 upon 6 into 6 upon 6 plus 6 means 3 ohm, right? So we'll make a equivalent circuit of this. So this is going to be this is 3 ohm. This is B. Okay, so what I have done is in this circuit these two are in parallel, right? So 6 into 6 we have got the equivalent, we find the equivalent circuit. So this is this equivalent resistance, right? 6 into 6 upon 6 plus 6, 36 upon 12, right? This is 3 ohm. So this is 3 ohm. So this is 3 ohm is the equivalent resistance of these three resistors. Okay, this is, and this is 3, this is 3, and this one, right? Now in this loop, in this loop, loop 1 and loop 2. In this loop, what we are going to do, we'll use KVL. Okay, in loop 1, KVL will use it. So this is going to be this is 10 volt, right? 10 volt. So this is going to be 10 minus 3i minus 3i minus 3i, right? Equal to 0. So this implies 9i equal to 10, or implies I equal to 10 by I equal to 10 by 9. Okay, I equal to 10 by 9. So now this is the one, this is the 10 by 9. Okay, so now in this loop we'll use it because we are going to find V Thevenin, right? Okay, in this loop this is, and we know V Thevenin equal to VA minus VB, right? So here we'll use it. This is going to be VA. Here we are going to use this. Okay, in this loop. So VA minus this is 3I equal to this is VB, right? So from here this implies VA minus VB, VA minus VB is going to be 3I. 3I value we have, right? This is 10 upon 9. So this is going to be 10 by 3. That is VTH. Okay, this is VTH. Okay, now this is the VTH we have got. Now we'll make equivalent Thevenin circuit. Okay, so this is going to be like this. This is the volt. This is R Thevenin. and will connect this to 2 kilo ohm resistor. Okay, 2 kilo ohm resistor, and this is 2 kilo ohm. This is voltage. VThevenin is 10 by 3. Right? 10 by 3 volt. That is VThevenin. This is RThevenin. Okay. Right now we can easily find out this one. Current through this resistor I 2 ohm is going to be VTH. Right. This is 10 by 3 upon 2 plus 2. Right. So this is going to be 10 by 12. Right. 10 by 12. And this value is going to be 10 by 12. This is going to be equal to 0.83 ampere. Milliampere. My apologies. Milliampere. In kilo ohm. Right. So this is milliampere, and this is the answer, guys. So this is the question. I hope you have understood it. Now there is one question related to RC circuit, which I'm going to solve for you now. Okay. Okay. Next question. It's a good question, guys. So next question is: so we have been given a circuit, 3 volt. This is 3 volt. Okay. And then is a key. Okay. This one. This one. And this is V output. Okay. V output. V output. This is C. This is 2 ohm. Okay, this is 3 volt, and this is V output. Okay, so we have to find, and we have been given, guys. Okay, we have been given dV naught upon, this is V naught, guys. Okay, dV naught upon dt, this value is given, that is minus 10 volt per second, and also we have been given value of V naught. This is function of t, right? Is given 2 volt, or we have to find out the capacitance C. Okay, so this is the question. So we are going to solve it. So first, guys, we have a formula, right? I have already explained in my previous lecture. Qt is Cv into 1 minus e to the power minus t upon Rc. Okay, minus t upon Rc. T upon Rc. Okay, this we know. So now this we know. This is 3 ohm, 3 volt. This is 2 ohm, and this is the C, guys. Okay, capacitance. And this dv naught upon dt is given, and v naught t is given, guys. Okay. So this is the one. And now what we are going to do is, since we know q is equal to cv naught, right? Q is cv naught, right? So from here this implies value of v naught is going to be q upon c. V naught is output voltage. Okay, q equal to v naught. Okay, cv naught. This v is this, guys. This v is this one, 3 volt. Okay, this is v naught. V naught equal to q upon c. Now, so now what we can do is in this equation we can find out this one. this one. Okay, so we can divide this by C. This is going to be Q upon C. Q is function of T. Okay, Q upon C. We have divided this equation by C. Okay, so this is going to be CV upon C into 1 minus e to the power minus T upon RC. Okay, now Q upon C equal to V naught, right? This we know. So this is going to be V naught equal to CC will get cancelled, V into 1 minus e to the power 1 minus e to the power minus T upon RC. Okay, this is the equation, guys, or we can write this is equation number 2, we can say, and this is equation number 1, or we can write this V naught equal to V minus V e to the power minus T upon RC, or we can write from here V, I'll write in next page, V e to the power minus T upon RC, this one, e to the power minus T upon RC, this is going to be equal to V minus V naught, V minus V naught. This is equation number 3. Okay, this is equation number 3. Okay, so now what we can do is from equation 2, differentiating equation 2 with respect to T. Okay, so from 2 to what we can write this one to dV upon dt, dV naught upon dt, dV naught upon dt equal to this one. I will differentiate this with respect to T, right? So this is going to be V minus 1 upon RC. So this is going to be minus V into 1 upon RC, and this is going to be, this will be 0, right? RC e to the power minus T upon RC. I have this, so what I have done is I have differentiated 2 with respect to T. Okay, so this is going to be e to the power minus T upon RC. Okay, e to the power minus T upon RC. So from here we can write V e to the power minus T upon RC. This value is going to be equal to minus RC dV naught upon dt, minus RC dV naught upon dt, right? So now this is the one, guys. Okay, so from here, and this sign will be plus, guys, because here we are differentiating, right? Minus and minus minus plus. Okay, so this sign is going to be plus, this is plus. Okay, now what we can do is, this is equation number 4. So we can put the value of 4 in 3, right? From 4 and 3, from 4 and 3, from 4 and 3, this value we can write this one, right? So this means RC V naught upon RC, this way in this so in equation 3, in place of V e to the power minus T upon RC, we'll write RC dV naught upon dt. Okay, so this is going to be RC dV naught upon dt is going to be equal to V minus V naught, right? V minus V naught. So this is going to be RC value, we have resistance is given, right? Here 2 and V is 3, so we need to find. So R equal to 2 into C dv upon dt is given, right? dv naught upon dt is given. This one 10 minus 10 minus 10 into v is 3, v naught is given 2, v naught is 2, right? So this is going to be, so from here minus 20c is going to be 1, or c is going to be minus 1 upon 20, or equal to minus 0.5 microfarad, right? Or we can write mod of c, value of c we need to find 0.5 microfarad, okay, 0.5 microfarad. So this is the answer, guys. This is the answer. Next, next is that this is also good topic, guys, that is T network and pi network, okay. Okay, so T, or we can say star, and pi is called delta. Star or delta networks. Very important, okay. So we can solve complicated networks easily if you know it, okay. So T and pi network, okay, pi network. So I'll write here. So I'll make a T network first, okay. So this is like this. Okay, so this is T network, guys, okay, and pi network is going to be like this. This is, guys, you need to understand this order, okay. This will be Z1 and this will be Z2, guys, okay, and this will be Z3. This order is very important. This Z1, this Z2, and this Z3, okay, and this is ZA, this is ZB, and this is ZC, guys, okay. This order is very important. So for T network, it is Z1, it is Z2, and it is Z3. For pi network, it is ZA, ZB, and ZC. So now we can easily convert T network into pi network, and pi network into T network, okay. So I'll write the formula here. This is very important, okay. Z1, Z2, Z3. This is ZA, ZB, ZC, okay. Now we'll write the formula for it, okay. Now we have to convert pi network into T. Okay, so we have a pi network, this one, and we have to convert this into T. So how we are going to do it, okay, by formula, okay. So this is going to be pi to T. Pi to T means we'll convert this pi network into this T network, okay. So then the formula is going to be pi to T means we need Z1, Z2, Z3, right, for making pi. So Z1 is going to be very important, ZA, ZB upon ZA plus ZB plus ZC, okay. And now we'll find Z2. Z2 is ZA, Z2 is ZB, ZC, ZB, ZC upon ZA plus ZB plus ZC. And similarly, Z3 is going to be ZC, ZA upon ZA plus ZB plus ZC. Okay, this one. ZC, ZA equal to ZA plus ZB plus ZC. Okay, make sure that the order should be this order, okay, then this formula will be useful, will be applicable, okay. this one. So we have converted that pi into t. This is the formula for pi into t. Okay, so we have z1 za zb zc. Now we need to find z1 z2 z3. For converting pi into t, we use this formula, but make sure these z1 z2 z3 and za zb should be in this order. Okay, then this formula is applicable. Okay, this is z3. Now second is t to pi. Now we have to convert t network into pi network. Okay, t to pi. In t to pi, so this t we have to convert into pi, means we need za zb zc, right? So this is going to be za. These are z1 z2, right? Now we need za. So za is going to be very simple, z1 z2 plus z2 z3 plus z3 z1, okay, upon za means z2, okay, and zb is going to be z1 z1 z2 plus z2 z3 plus z3 z1 upon z3, and zc is going to be zc is going to be oh guys, just give me 1 second, okay. Zc is going to be just give me 1 second guys, okay. Zc is going to be this one, okay. Zc is going to be z1 z2 plus z2 z3 plus z3 z1 upon z1, okay. So this is the za value, zb value and zc value, okay. So these are the zc. So very simple guys, for za z1 z2 plus z2 z3 plus z3 z1 upon z2, okay. For zb z1 z2 plus z2 z3 plus z3 z1 upon z3, okay. For zc z1 z2 plus z2 z3 plus z3 z1 upon z1, okay. So these are the value of za, zb and zc. So we can easily convert the pi t network into pi and pi network into t by using this formula, okay. Next is we are going to study, that is parameters for four terminal network, okay. Parameters for four terminal network. Parameters for four terminal network, okay. So parameters for four terminal networks, okay. So there are so first parameter is z parameter. So we are going to study z parameter today, okay. Z parameters, okay. Z parameters. So here this one is Okay, so this is the four terminal network. Okay, and the current is here I1, and at this point current is I2. Okay, and there's a potential is V1 in between this, and in between this V2. Okay, and from here we know V equal to IZ, right? Z is the impedance. Okay, so Z parameter, this is also called impedance. Okay, impedance. Z parameters, is called impedance, right? So this is the four terminal network, guys. Okay, now I'll explain the Z parameters. Okay, and or this is the impedance. Okay, so for understanding this, you need to understand two things, guys. Okay, which is very important. This is V1, V2. Okay, this is I and this is I. You need to understand this. IRFO, okay, IRFO. So this is IF. So or you can say IRFO or IRFO. Very important. Okay, I is known as, that is input. Okay, I is input. R is reverse. R is reverse. R is reverse, and F is, this is F is forward. F is forward, and O is output. O is output. Okay, IRFO. We can say IRFO, right? IRFO. So this is IRFO. Okay. So here I'll show you this one. Okay. So this is so what I'm going to do is I'll write it directly. Okay. Then so that you can understand. So we need to know this one, IRFO, or we can say IRFO. Okay. Or we can also say IRFO. Okay. So I as in input, R as in reverse, F as in forward, and O as in output. Okay. So now this is V1. So here we need to understand this. Okay, so Zi will find this impedance. Okay, this is Z parameters. Okay, impedances, Z impedances. So as Zi, Z input is going to be, this is a formula, guys, you need to note down, V1 upon I1. So this is V1 upon I1 at I2 equal to 0. Okay, and then ZR, the reverse impedance. Okay, this is going to be V1 upon I2 at I1 equal to 0. Similarly, that ZF, okay, Z forward. Okay, Z forward is going to be V2 upon I1. V2 upon I1 at I2 equal to 0. And similarly, there are four parameters of Z, right? And then ZO, Z output, that is going to be V2 upon I2 at V2 upon I2 at V2 upon I2 at Z equal to V2 upon I2 at I equal to 0. Okay, at I equal to 0. At I1 equal to 0. Okay, at I1 equal to 0. So these are the values, very important. So Zi is V1 upon I1. Okay, and Z2 equal to, sorry, ZR equal to V1 upon I2, and ZF equal to V2 upon I1, and ZO equal to, Z output equal to V2 upon I2. Okay, these are the condition. Okay, well, so these are the value of Zi, ZR, ZF, and Z0. Okay, this you need to understand. Now I will solve one question, then it will clear your all doubts. Okay, so I'm going to solve questions. So these are very important formula, guys. you need to note down. Okay, this one is okay. This is Zi, Zr, Zf, and Z0, and these are the conditions. Okay, so now using this formula, I'm going to solve one question, and it is going to clear your all doubts. Okay, so question we have this one, guys. This one. This, okay, this one. This is O. This is O. This is O. So this is 1 ohm. This is 1 ohm, and this is 2 ohm. Okay, so this is V1. Okay, and this is V2. Okay, this is V1, V2, and this is this. Okay, and this is so and this is 1 ohm, this is 2 ohm, and this is 1 ohm. Okay, this is the question, and we need to find that Zi, Zf, Zr, and Zo. Okay, so this you need to note down IRFO, or we can IRFO, or we can say IRFO. Okay, so IRFO. So Zi, Zr, Zf, and Zo we need to find out. So very simple. So for this, we can say you need to understand the current at this is I1, guys, or this direction you need to understand. Okay, this is the I1 current, and at this point the current is I1. Okay, this is also I1. This is the direction you need to understand. Okay, and this is the direction of current I2. So this is I1 current, this is I1 current, this is I2 current. Okay, and this is I1 minus I2, I1 minus I2. So this is I1 minus I2. This is I1, this is I2, this is I1 minus I2, guys. Okay, so now we'll use. So this is going to be in one loop. So we'll use in one loop. We'll use KVL in loop 1. Okay, KVL. So KVL, if you use it, so this is going to be V1. This is the voltage at this across this points. Okay, so V1 minus this is 1R. 1R means minus I. 1 ohm means 1 into I minus I. Okay, this is minus I1. I1 is the current. Okay, I1, and this is going to be minus this 2 ohm, 2 into I1 minus I2, 2 into I1 minus I2. Okay, and that is going to be equal to 0 in this loop, and we'll simplify it. This is going to be V1 minus I1, okay, minus 2I1 plus 2I2 is going to be equal to 0, or we can write V1 minus 3I1 plus 2I2 is going to be equal to 0. Okay, this one. Now in loop 2, in loop 2, I will use the KVL. So this is going to be, this is V2, right? So V2 minus this this is 1 ohm, right? This is I2. 1 into I2 is I2, right? I2, and this is R, right? And this is, so here we are going to use it, right? So this is going to be this one. This we have used I1 minus I2, right? And this at this point we are using, this is I2, this is going to be I2 minus I1, right? So this is going to be minus 2 into I2 minus I1. 2 into I2 minus I1 equal to 0. So this is going to be in this loop, okay? I2, and in the, here in this loop I1 minus I2. Okay, this one. So in this case we'll use V2, and this is going to be minus 3I2 plus 2I1 is going to be equal to 0. V2 minus 3I2 plus 2I1 equal to 0. This is equation number 2, guys, and this is equation number 1. Okay, now what we are going what we need to find, that z parameters, right? That we know this formula, right? We just need to write this therefore. So first we'll find zi. We'll find zi, and we'll find this for zi and zi and zr for in this loop, and for from 2 we'll find zf and zr, right? Zo, my apologies, zf and zo. So now we'll find this first zi. Zi equal to, we know zi equal to v1 upon v2, sorry, v1 upon i1 at i2 equal to 0, right? So in equation 1 we'll put i2 equal to 0. I2 equal to 0, this one, I2 equal to 0 means this v1. So I2 equal to 0, it means v1 minus 3i1 equal to 0. So it means v1 upon i1 value is going to be 3, right? So z1 is going to be v1 upon this one, right? So this is going to be zi is going to be this one. So I2 we have put 0 in equation 1, right? This 0, so this is this means if you put I2 equal to 0, so then v1 upon I1 ratio is going to be equal to 3, right? So this is going to be at I2 equal to 0, this is 3 ohm. Now similarly we'll find z ir4, right? Ir zr, we'll find zr. So zr is going to be v1 upon I2 at I1 equal to 0, right? So zr is going to be here. In this equation we'll write I1 equal to 0. I1 0 means this term is 0, then v1 upon I1 value is going to be 2. This is 2 ohm. Zr equal to 2 ohm. Very simple, 2 ohm. Similarly, we'll find zf ir4, right? This we need to note down, that's all. ir4 or irfo. Okay, so zf is going to be that v2 upon I1 at I2 equal to 0, right? So this means, this implies at I2 equal to 0, right? So the value of this is going to be in equation 2 will find, right? I2 equal to 0, I2 will make a 0, right? So v2 upon I1 value is going to be 2 ohm. Okay, now we'll find last final term, that is zo. Zo is going to be v2 upon I2 at I1 equal to 0, right? At I1 equal to 0, so that implies that is going to be, so in this equation we'll put, so for zi, for zf and zo, we'll put I1 I2 0 from equation 1. So for finding zf and zo we'll use equation 2, or for finding zi and zr we'll use equation 1. Okay, so v2 upon I2 is going to be, here we have to put I1 equal to 0. I1 0 means this v2 minus 3 I2 equal to 0, it means v2 upon I2 is 3, that is 3 ohm. Okay, this is the answer, guys. I hope, guys, you have understood it. Okay, so these are the z parameters, okay, impedance parameters. Okay, you just need to note down this ir4, and you can easily find zf, zr, and these are the formulas, guys, you need to note down. Okay, this is important formula. Zf is this one. Okay, well, guys, before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also I would request the student who haven't subscribed my channel yet, please subscribe my channel, okay, and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also, guys, I would request the students please share my lectures details to other to your friends, so that they will also be able to watch my free live lectures and will be benefited by it. Okay guys, thank you so much. Bye now.